In solving for the 6 trigonometric ratios, we just need to understand what angles are being referred to, and we need to make sure that the 3 measurements of the 3 sides, or all the measurements of the sides of the given right triangle, are given, so that we could come up with an exact value and not an algebraic expression. So here, we are going to solve for x first, before the 6 trigonometric ratios of angle theta first, and we will have angle alpha. In solving for x, we are going to use the Pythagorean theorem, since x is one of the sides, and we have 2 given side measurements here. Specifically, x is your hypotenuse. So x is hypotenuse, and using the Pythagorean theorem, we can solve for the square of the hypotenuse is equal to the sum of the squares of its legs. So you can just write here 5 squared and 12 squared. And they can be rearranged because addition is commutative. So x squared is equal to the sum of 25 and 144. And further, x squared is equal to 169. Don't forget that when you take the root of both sides, you can always have 2 different answers, plus, minus, the square root of 169. In this case, plus minus 13. But since x is the side measurement, we'll only accept positive 13, and you can have here units, since we don't have exact given unit of measurement for the length. This 13 will be used now to solve for the 6 trigonometric ratios of theta and alpha. As in doing that, let us try to extend here. We can have more spaces. So we will start with the 6 trigonometric ratios of angle theta. Now for angle theta, you just need to understand what is the opposite side, the adjacent side, and of course, x being a 13 is always your hypotenuse. With reference to your angle theta, 5 here is your opposite side, or the side of the measurement of the side opposite the angle theta, and this will become your adjacent. In doing so, we can solve the 6 trigonometric ratios easily. Let's start with the first trigonometric ratio, cosine of theta. Cosine theta is given as the ratio of adjacent and hypotenuse. So adjacent over hypotenuse. And the value for the adjacent side is 12. Hypotenuse is 13. This is cosine theta. No need to give the value in decimal places because this is the exact value. Next, we can solve for sine of theta. Sine uses the ratio of opposite over hypotenuse. The value for the opposite side is 5, and you will have 13 as your hypotenuse. And lastly, you will have, not lastly, third, you'll have your tangent theta, which uses the ratio of opposite and adjacent. Opposite side is 5, and the adjacent side is 12. So these are the first 3 trigonometric ratio for angle theta, which is taken or using the mnemonic SOH-CAH-TOA. We just start with the cosine, but you may of course start which trigonometric ratio is easier for you. We have SOH-CAH-TOA. We are not yet done because there are 3 remaining ratios for theta. And the first one is cotangent. Let me write cotangent here so that I could explain further the reason why, or the explain further its ratio. Now, cotangent is just the reciprocal of tangent. So I'm just writing it here so that you could automatically compare. So it's actually the reciprocal. So you reciprocate the ratio instead of O over A, that's A over O. And the 5/12 will also be reciprocated. 12/5. The next one is secant theta, which is the reciprocal of cosine. So instead of A over H, you have H over A, and simply reciprocate the value. You will have 13/12. And finally, for cosecant theta, it's theta. It's the reciprocal of sine theta. So you'll have here H over O. You will get the result 13 over. So these are the 6 trigonometric ratios for angle theta. It's given a figure. Just need to remember the mnemonics of the TOA and the relationship of the reciprocals of the first three trigonometric ratio, meaning reciprocals simply interchange the values of your denominator and numerator. That's for theta. We are still going to look for the trigonometric ratio for angle alpha. Angle alpha, let us use different color so that it would not be confused. Let's use this color here. So if angle alpha, H is still H. No need to worry about that. But we're going to exchange or interchange the opposite and adjacent sides. Here, 5 is the side measurement of side opposite angle. But right now, it's no longer the opposite side for angle alpha, but it is now the adjacent. Around here, which was the adjacent side of angle theta, becomes your opposite. So for cosine theta, which is adjacent over hypotenuse, your adjacent side is no longer 12, but for angle alpha, it's 5 over 13. Hypotenuse is always hypotenuse. Next, sine. Sorry, it is no longer theta. This is alpha. So let's have sine alpha. Still, the trigonometric ratios or the technique in solving trigonometric ratios will not be changed. It's still opposite over hypotenuse. It's just that the values are now not the same for opposite and adjacent. It's 12 or 13. Before going further, let's try to examine the difference when we talk about cosine theta, sine theta, cosine alpha, sine alpha. Since the adjacent and opposite sides were just interchanged, look at the values. The cosine theta, which is 12/13, became the sine of the second angle, reference angle alpha, 12/13. It's also true with your sine, 5/13 earlier for theta. It becomes your cosine alpha, or your reference angle nu, to your tangent. Tangent alpha. Since the opposite and adjacent sides were interchanged and you are not going to change the formula for the ratio, the opposite now becomes 12 per 5, which is the reciprocal of tangent theta, or basically equal to cotangent theta. 12 over 5, that's tangent. Complete, simply look for the remaining values. Second alpha is just the reciprocal of your cosine alpha. So automatically, you can write this one 13 over. Second, alpha is the reciprocal of sine alpha. So that's 13 close. And your cotangent alpha is the reciprocal of tangent alpha. This becomes 5. So these are the 6 trigonometric ratios for alpha, and earlier the 6 trigonometric ratios for theta. After giving the exact value or finding the exact value for the remaining side of this given triangle.